I'm Aiden from Team 10430 Duck Center Construction. We're going to be just giving a guide to 3D printing. So let's talk about the actual 3D printer itself. So there are many different types of 3D printers out there. These two are the most common types you'll find. FDM, which is the most common type, it's the printer that we have over there. It uses plastic-based filament to extrude parts out layer by layer. And then the other type that you'll also find is SLA, which uses liquid-based resin to cure parts layer by layer. So actual parts to your 3D printer. So there's the part cooling fan in back there. That fan will cool your part as it's being extruded onto your bed. The extruder is what extrudes the filament out onto the bed, and then the heater and thermistor is what heats up your nozzle and hot end to melt the filament, and the thermistor measures the temperature because different filaments print at different temperatures. And then for axes, your Z-axis motor here controls the up and down. This one, this style of printer moves the extruder up and down. X-axis motor is here. It moves the extruder left and right. And then Y-axis is in here. It moves the bed forward and back. Different printers do it different ways. Some have the extruder move on the X and Y axis instead of the Z and X, and have those ones will have the bed move up and down on for the Z axis. So, why should you 3D print? 3D printing has a lot of different uses. So you can rapidly prototype parts. So something my team likes to do is we make a design, print it, test it, see what changes need to be made, redesign, and then over the night we'll print the new version and then test that next meeting, and we'll just continue that process over and over again until we have a final design that we'd like. You can make very unique and custom parts. So for this robot here, we needed a very compact and small mount for this motor and the gear train. There was no mounts that you could just buy that would be able to achieve that compact and fit the gear train, so we just made our own mounts that would achieve what we needed it to.
So it's the white piece on the top.
White piece right here.
If we were to just have the motor sticking out, then we would be past the height limit, so we needed a compact solution.
Yeah. And you can also make very complex systems, like this one here, which is the grabber design that was originally intended for this robot, or that arm there that was made by one of our retired sister team 7588s for a previous season. And then you can also make replaceable parts. So any things go wrong in matches. So on this robot, this arm here that swings out, that would be used to push the game pieces around. We knew that if something wrong were to happen, if it hit a wall, another robot were to run into it, it could snap very easily. So we just ended up printing a whole bunch of extras, and if something ever went wrong, we knew we could very easily and very quickly replace it should something have gone wrong. So sadly, 3D printing is not a solution for everything. Anything that needs to be like precise manufactured out of metal or other things such as mainframes, U-channels, screws and nuts, you should just buy them because 3D printed, obviously aluminum is stronger than plastic. So really those things should be bought or manufactured out of metal instead of trying to 3D print. But this shouldn't deter you from attempting to 3D print stuff, so definitely experiment. Some teams have successfully made entire drivetrains or robot chassis with 3D printed parts, so definitely give it a shot. So there are a plethora of different filaments to choose from. These ones are the most common that you'll find in robotics. PLA is kind of like the default filament out there. It's very cheap. Rolls range from $15 to $20. It's very easy to print with, and it's also very rigid, so it will hold its shape no, it won't flex or anything like that. And then, but with it can't handle high stress or impacts that well, so it will snap or crush if anything were to hit it as hard. So, you want to use it for, so anything that you don't want flexing or, most things will use PLA, so anything that you don't want to flex, like gears or adapters. So on this clock here, you can see the gears. We can pass this around if you guys want. So you can see that's stumbling, sorry. So PETG is another filament type. It's also cheap like PLA, rolls ranging from $15 to $25. But it can handle higher stresses much better than PLA. But this is due to its slight flexibility. So you can see here, this part, it does kind of flex a little. It's before it snaps. So PLA, PETG will like to flex before it snaps. And it is slightly harder to print with. So if you want to pass this around, try flexing it a little bit. It is slightly harder to print than PLA. It does work occasionally. You want to use it for anything that is going to be under a lot of stress or deal with some sort of impact. And so TPU is a flexible rubber-like filament. So you can see it's very bendy here. It has a nice grip to it as well. The cons are it's relatively hard to print with. TPU, likes to warp and can suffer from stringing a whole lot. So you can see a bunch of bits of filaments just coming off. Anything, you'd want to use it for anything that is you want to flex. Pass that around too. Anything that you want to be flexible, so things like intake rollers or flippers. And then ABS. ABS is the strongest filament that you can print out of. So it's very rigid, strong, has high heat resistance, but it is the hardest filament to print out of. ABS loves to warp. Sometimes parts can shrink as well. It requires an enclosure to print. So the enclosure is meant to keep the air around the part warm as it's being printed. And then the fumes ABS do produce when being printed are legally considered toxic. They are more of an irritant and just have a strong smell. Anything that you want as strong as possible, so on this robot, these hooks here that we would be climbing with are printed out of ABS because we knew we needed these as strong and rigid as possible so that they would never snap whenever we would climb, because they would have to support the entire weight of the rope. And some practices to keep in mind: keep your bed clean. So your printing bed can get dirty from anything like fingerprints, grease, grime, dust, debris, glue. A dirty print bed can lead to many different issues that can cause print failures. So when cleaning it, you want to use warm water and soap. So like some Dawn dish soap will work for cleaning your bed. If you want a quick and dirty solution, isopropyl alcohol, wipe it down, or Clorox alcohol wipe can also work. But that will only get the base fingerprints or dust off. So even if your prints are still not sticking to the bed and you're still having issues, you can use glue, brims or glue to help keep your print on the bed. Brims are just a slicer setting that adds extra perimeters around your first layer so that there's more surface area for the part to adhere to the bed for more surface adhesion. If that doesn't work though, and you're still having issues, as a last ditch effort, you can use glue, like just an Elmer's purple glue stick, get a thin layer on, and that should work just fine. Do keep in mind, glue can lead to a dirty print bed, so do clean it after you use glue. And then finally, print orientation. So back to how FDM printers work, they make parts layer by layer. And they love to snap on those layer lines. So you want any force or load to go against the most surface area of your load, so that it's, instead of dealing with just one layer line here, it would be going up against the entire part here and all the other ones as well. There is a bit of a trade-off though with print orientation. Sometimes the strongest print orientation won't always be the easiest orientation to print it out of. This can increase your print time or increase the amount of support material that's needed. And then there are a lot of different issues you can run into when 3D printing as well. These are the most common ones. A bad first layer is whenever your first layer comes out bumpy or like kind of separating from the lines, and or it's just lifting off your bed a little bit. It can be caused by a dirty print bed. So again, keep your bed clean. It can also be caused by your nozzle being either too close or too far away from your bed when it's printing the first layer. Some printers have a first layer calibration test that you can do that will help you adjust how far away the nozzle is. So look into your printer's manual or printer's website to find out more. And stringing. So stringing is when strings of filaments will lift off into the air from your part. So this here is actually a stringing test part that you can print. It will test for stringing. So stringing can be caused by either your temperature of your nozzle not being hot or cool enough, but most of the time the reason for stringing is just bad filament. Your filament likes to absorb moisture from the air and cause little microscopic air bubbles, and it's those microscopic air bubbles that will cause the stringing. And warping is one of the most common issues you can run into. It's whenever part of your print just lifts off the bed. It can be caused by a dirty print bed, so again, keep it clean. And it can also be caused by a cool breeze or draft, so just like air circulating around your room can cause warping. So to solve it, use brims or clean your bed, use brims or glue, and make sure there's no like AC vents or open window blowing on your print. Then layer separation. Layer separation is when two layers on your print start pulling themselves apart and separate. So this can be caused by, again, that cool breeze or draft, just air circulating around your room. It can also be caused by bad filaments with those tiny microscopic air bubbles, or it can also be caused by your nozzle temperature being too hot or too cold. Sadly, layer separation does require a lot of experimentation, and it's just not fun to deal with. And then finally, how can you guys as rookie teams get started? So if you want STL files that are already ready to print, and ready to print, you can go to websites like Thingiverse, Makerworld, or Printables. They will have STLs or step files that are just already made designs that are ready to be printed. You can Makerworld is from Bamboo Labs and Printables is from Prusa, but the files off of those websites will work on any printer that you have. So if you want to design your own parts, there are different computer-aided design CAD softwares out there. I know Nordic Storm had a presentation on it during session 1. If you went to that. So different softwares are Onshape. Onshape is online, it's free, so all of it's, so Onshape can run on something like your school-issued Chromebook or even the mobile app, which Onshape does have. And all your documents are stored in the cloud, so you don't have to worry about any storage issues. And a cherry on top for Onshape, it also has completely free lessons that will teach you how to use the software. SolidWorks is the one that professionals use because it has the best features for professionals. It can be complicated but with more features comes more complexity to how it works. It's free for FTC teams and FRC teams as well. But it's not online, so all your documents have to be stored on your device or a server if you have. And you do require a pretty beefy computer to run SolidWorks properly. And then finally, Fusion 360 is like in between. It has more features, but it is complex to learn as well. And then if you want to get started printing your own parts, the printer we recommend that rookies start out with is the A1 or A1 Mini from Bamboo Labs. They are cheap for today's markets of 3D printers. They are easy to set up, easy to build, and very reliable printers.
I believe they're on sale right now too, right?
Yes. Again, they mentioned it in the big presentation earlier today. Stratasys, you can get parts from Stratasys can print parts out for FTC teams because they've partnered with High Tech Kids. They're just a 3D printing company that will have 3D printing services. And then finally, but Stratasys does take a bit of time. They can get your parts to you within a couple of weeks to a month. But if you don't have that time, we can get your parts printed for you. Just email us at ftcburnsville@gmail.com with your STL file and choice of filament. We can print any of the 4 filaments mentioned earlier in the presentation, and we can get your parts back to you within a week or less. So, any questions?
Me? You mentioned some of the material is toxic. So what do you do? Like, do you just click print and walk away, or what do you typically do?
So because ABS requires an enclosure, most ABS printers will have ventilation that will deal with those toxic fumes already.
Okay.
Yeah, so for those, you can technically print ABS. So for enclosures that have it, they'll have a carbon filter or a carbon activated filter. You can either have it so you just have like a fan that's blowing the air out into like a window, or you technically could just do the print and walk away, and then when it's done, just open up a window or something, and then the air will just kind of vent out. But technically, with like printers that are set up to do it, the enclosure will have a filter inside of it that will filter out the particles and then just blow the hot air into the room that it's printing in. But if you don't have one of those and you do want to print ABS, technically you can just print it, kind of just walk out of the room for however long, and then when it's done printing, just open up a window and you'll be fine.
So you were talking about how you have to keep filament dry. What if a filament already gets like a little bit wet? Is there a way to like dry it? Or I know I've seen some things where like you can put it in like a special box and to keep it dry.
Yeah, so there are ways to dry your filaments. There are filament dryers that you can buy, or some people have modded food dehydrators to also dry filaments. And then Bamboo Labs also, for their bigger printers, have I forget what it's called exactly.
So yeah, they have one's called the AMS Pro 2. But for normal printers, like smaller printers, if you already have a small printer, you want to keep your stuff dry. If you just put your filament in a food sealing bag, or you just put it in a sealed box with it's called desiccant, but it's silica gel packets. You sometimes will see them in food and they'll say do not eat on them. Those are actually what you use to dry filament. So if you are going to store your filament for long periods of time, you can put them in a sealed box and put silica packets in there. You can buy them online, they're very cheap. Or I use a food dehydrator for mine. You just can put it in for 5 hours or so, or you can buy online. They do sell filament dryers where you just put it in, press go, and just walk away.
Oh, and also, what's a good like enclosed printer for printing the toxic films?
So the one that I would recommend is an X1 carbon, but those are like $1,000 to $2,000.
I would.
Okay, what's like a good one?
I would, unfortunately, ABS is a little hard to print by yourself. I mean, you can definitely, like, I have an A1, a Bamboo A1 printer, and I can print ABS. I had to do some modifications to my printer to get it to do that. I have basically a little tent it sits in, and that is my enclosure. The problem is you have to kind of understand the limits of what you're working with. You're using a machine for something it shouldn't technically be doing. But if you do want basically a buy solution where you buy it and you don't have to worry about it, it fortunately does cost about $1,300, but it is a Bamboo H1S, or is the H1S and H2S. Unfortunately, ABS printing is really hard to do. It's a really hard material to print, and it does require a lot of money, but you can experiment with it on lower end machines to see if it even works, but I wouldn't be surprised if it doesn't work.
Okay. One more thing, I saw those like please take one. Can we keep those?
Yeah.
Yay.
So those are just little keychains. Our email is on the back. So if you have any questions, they don't have to be 3D printing related. You can ask us about programming, CADing, or just anything robotics related. You can reach out to us through our email.
But also, why is the duck's body running?
It's a robot.
Oh. So I noticed when I look at this 3D printer, most of it kind of looks 3D printed.
Yeah, some 3D printers do use 3D printed parts. That is a thing.
The H2D is one of Bamboo's they're one of their more advanced printers, and it is pretty expensive. It costs anywhere from, I think it's $1,800 to $2,500. That's because it has 2 nozzles on it. It also has the ability to do laser engraving or laser cutting and vinyl cutting. It's kind of a all-in-one printer that you buy if you want to do a little bit of laser engraving, a little bit of vinyl cutting, and you want 2 nozzles on your printer. So it's really expensive, but it is an all-in-one solution for people. So that's why it's that much. But the H1S is the one that just has 1 nozzle on it, a little bit cheaper. You can do all the filaments, easily. It has an enclosure, heated enclosure. Will take care of the fumes and everything like that. Hopefully that answers your question.
So you mentioned load. Thinking about the orientation that we print the parts in, and that has an impact on load. Some of the tools that you shared with us for CAD, I'm curious if those softwares have any features that would let us choose a specific filament type based on the load that we are expecting on the part.
So I know Onshape does have, so for structural analysis, I'm not sure if they have tools specifically for filament type, but I do know that SolidWorks will definitely have something like that. Onshape, I think, has a structural analysis tool. You may have to pay for it though. Onshape is really good for being free and collaborative, but they do have a couple features like structural analysis that are behind a paywall, unfortunately. But I know SolidWorks and Fusion 360 can do structural analysis. I'm not so sure about Onshape, but they do exist, and you can put in the material type, and it will show you a graph of where it would snap or where the most load would be on it. So for sure.
Another question. Could the laser cutter do thin metals?
So yeah, on the H2D you can do, I think it's like, I don't know if you can do, maybe you could be, I think if I remember correctly from the documentation, you can do like maybe a 2 to 3 millimeter aluminum. I wouldn't really, I would say that it's more for like leather and like woods, like kind of like a little like thin wood, and maybe some plastics. I wouldn't necessarily try cutting metal with it, I don't think it's necessarily powerful enough to cut metal. If it is, it's only very thin aluminum. But I would look into something, if you want to actually do something more serious and big, I would look into like an actual dedicated laser. But I know people don't have unlimited funds for a 3D printer and a laser cutter and all these things.
And then has anyone not gotten that keychain that wants one?
Can I ask about the arm as well? You mentioned the way y'all approach it is by creating replicas. Why not just use metal arm? Was it a weight consideration?
It was more like a gameplay consideration. Like for example, in one of our practice matches or something, one of our drivers accidentally let down the arm, and the other driver turned it so that in a way that it snapped. And if it was made out of metal, of course, you know that wouldn't. It would hurt the metal that it was made out of. It was just easier for us to use 3D printing to mass produce those just in case of a snappage, and there wasn't any other benefits to using metal in that scenario.
I'll also say that when you are able to 3D print parts, and especially CAD is extremely important. There are definitely a lot of parts online from the sources we said here, Thingiverse, Printables, Make the World, where you can get parts that are ready to print. But when you can CAD your whole robot, you definitely could have made that out of metal. But when you're able to see how your part works, big picture on the robot and how it meshes together, that's a really important part of CAD and 3D printing that it adds.